Hello.
Yeah, so this one works.
Hello. Talking to the mic.
Wow, everyone's a critic. All right. There we go. Good.
Okay. We're a bit late, like 10 minutes late, but we are gonna end right at 5:30. Okay, thank you everyone for staying with us for a long time, and I really enjoyed this workshop. I hope you did as well, right? And okay, as a moderator, I'm going to start with individual questions for each of you, and then I will ask everyone a few questions, and then we will take questions from the floor. Okay, the order is different. So, okay, I'm from Xiaohong. Okay, as we've heard today, there are many different language frameworks, including K, Redux, Sail, ES Meta, Spectec, and others. What do you think is unique about the K framework? What makes it particularly good compared to other frameworks? What compromises has the K framework has to make to be successful?
Thank you all for the question. So, I think based on my experience, so K is unique in how it's. If you look at the development of K, which really started 15 or even 20 years ago, it follows a quite different path than maybe other semantic approaches, tools. In a sense, as engineering first, engineering driven. So when K took the shape, and gets evolved and so on, there is no theory behind it, and we did that on purpose. Not by we, I mean the lab. That's actually before I joined the group. So actually and it's all driven by a very concrete engineering goal, which is let's define the semantics of C. Completely. So each and every corner cases like undefined behaviors, implementation defined behaviors, all of that is define all of them in something which we call K. So whatever that takes means we need it, right? For in a scalable semantic framework. So basically, in the first 10 years of the development of K, it's the process of defining real-world language semantics and see where's the bottleneck of the existing semantic approaches and how can we accomplish those bottlenecks. And most of the bottlenecks are on the engineering side. So if you look at semantic approaches like operational semantics, there are many variants, denotational semantics, axiomatic semantics, and so on. They all work great on small examples. Like they work very beautifully, very elegant. But you realize things start to break apart when you want to extend your language, right? So suppose you have a very simple side effect free language, and then somehow you want to add side effect as a feature. And you realize you're in a situation where you're fighting against the hard work you just have done. Why? Because everything that you defined in the past does not take side effect into account, and suddenly you have to go back and change everything. So that makes the development of a formal semantics of a language very non-modular. So it looks like you have to somehow have a very good understanding of everything you need at the point when you started, and that's just not realistic. So I think what's very unique in K is that it really takes into account of this, realistic considerations. A formal semantic approach that wants to be scalable must have this engineering, good support for notations, modularities, and so on. So I think that's probably one of the most unique feature of K. And then theory comes later, right? So once we get to a point where K becomes very stabilized, and then we sit down and sit back and look at it. Okay, so what is K? And then that's where the theory came in. I would say maybe 10 years after K, we started on K. So that's, I would say, what's unique about K. The other part, which is not very unique, but it's very emphasized in K, is the executability. I think Peter also mentioned that. So, of course, I think specification language can take various forms. But if you're talking about the canonical semantics, then that probably should be executable, because the only way that you want to test the semantics correctness is by massive testing, right? So you have massive test programs. You can test the semantics by running those programs and so on. Right. I think I'm probably taking too much time, so right.
Yeah.
Thank you. Yep.
Thank you. And Jonathan, you shared your experience at Google using symbolic execution for automated reasoning of P4. And what tools do you think are missing for automated reasoning of P4? And how can mechanized specifications help with that?
Great question. I think tools that are missing, one of the things that I would really like to see, and which I actually just told you we built, so you'll be a little confused, is a proper symbolic executor for P4. One that can take in a symbolic packet and output a set of symbolic packets going in the right way that is performant enough and where I trust the correctness enough that I can connect 64 of them together, say, to simulate a data center scale fabric. This would be a game changer for us. Even without the performance, it would already make a lot of our things better. The issue with the thing that I showed you is that we actually don't really rely on its correctness in almost any interesting way. This was maybe a little bit swept under the rug, but the thing that it says it comes out is not really used for diff testing in any particular way, right? We send it through this other simulator. If we really trusted this P4 symbolic thing completely, what's the point of having the second simulator? Well, that's a nice open source simulator used by more people, so we trust it more. How can mechanized specifications help? With that specifically, obviously it would be great if it was derived from some mechanized specification. But more generally for P4, I think there are a number of nice opportunities. There isn't really a particularly good, I guess there isn't really at all a reference interpreter. The thing that we use is this BMV2. There's another interpreter as well, and they use sort of different architectures. So even something like that would already be great. And as a PL person, I'm a huge fan of having a single source of truth, right? I would say that our community is quite a bit smaller than the JavaScript community. So we don't really have a particularly good process for how you make changes to the language. Important context here, I am also a co-chair of the P4 language design working group. So this is my fault, you should think. But I haven't been for very long, so it's probably still my fault. So I guess if I were to introduce such processes, I would love if they looked less like the WebAssembly from a few years ago, where you have to go through all of this stuff, which frankly, the networking people would just never do. And more like what I am hoping and assuming WebAssembly looks like now, where there's one small, well-defined thing, and everything else falls out.
As a co-chair of the language design working group, are you interested in having such a process for P4?
Absolutely. I was just talking to Michael about this. I'm not sure what I need exactly and how to make it lightweight enough to... We just have so few proposals now that in some sense we don't really even need a process, right? I can kind of just make it up as I go along. But I think there's a significant human cost to not having a process, which is you don't even know where to start, right? If you want to update some features, like if I'm not part of the group, how do I know where to go? How do I know how to pitch something to say this is a thing I'd like to be part of the language? Even if the process is uselessly simple, like come to this working group and talk to Jonathan, that's already better, right? It kind of gives you a way to approach the situation.
Yeah, I strongly agree with that. Yeah, and Michael. So you are one of the 3 editors of the JavaScript language specification and one of the first advocates of ES-Meta. You were so excited when we contacted you. So what made you so excited about ES-Meta and what are your thoughts on it now after using it? You already mentioned that.
Okay, ES-Meta is not the first attempt at mechanizing ECMAScript. As Philippa mentioned earlier, like her group had done this years ago for ES5 or 5.1, I believe, and only in strict mode. So some subset of it at that, and then like years before that. Arjun Guha and Sriram Krishnamurthy at Brown had done a mechanization of ES3, Lambda.js, long time ago. I was still in school back then, yeah. So those were great, but they were not useful, and I want to say that kindly because it's not that the work was not good; it's that they reflect this snapshot in time. And JavaScript as a language is constantly evolving, and the language at that time is no longer relevant, it's no longer used, it's constantly moving. So the important thing about ES Meta that really makes it stand out is that it's automatically deriving this mechanization from the spec. So as we update the spec, we are updating this mechanization and then all the tooling that derives from it. So that's what makes it really exciting because now it can actually be practically useful for us within the committee to do things like we do with it. Like automatically type checking the spec. So that really got me excited, and also the fact that when we worked together to do this implementation, we worked to get to a point where there was no really strong dependence. It's always a bit scary working with an academic project that you don't really know what the future of it's going to be like, and you don't want to tie yourself to it. Yeah, students graduate, they move on, and this is not a problem. I'm not complaining about that, but you can't really tie yourself to these kinds of things because you don't want to get stuck depending on it or trying to continue maintaining it yourself. So the fact that we got to a point with integration where we have the ability to add exceptions to certain parts that would then be excluded, and we can always we pin versions. We don't ever have it automatically bringing in new things. We can really be confident that we will always be able to continue moving without it being a hindrance, but always providing at least some help. So it was really great, and now we feel very good about our relationship there. Whether it continues to be updated as it is, which we're very happy about, or whether it doesn't and it still provides value.
Yeah, great to hear that. Thank you, Ralph. So you are the only one who suggested a question from these panelists. So that was tooling that ensures that a language spec has anything to do with real-world use of the language. That was what you wanted to talk about, right? So could you share your thoughts about it?
Sure. Yeah, I mean, basically, so before Mini Rust, our many years of work on this tool called Miri, and that is really what enabled me to do Mini Rust. So Miri is a tool that you can it's a testing tool. You can run your Rust code in it, and it tells you whether there's UB. It's testing, not verification, so it's only is there UB on the part of your lab where you're actually testing. It picks one of the many non-deterministic choices, so it's really kind of sampling there. But that this started as an experiment for me to have a ground truth that I was trying to figure out some of the gnarly bits of the Rust spec that I haven't even mentioned in the talk, stack borrows and tree borrows, for those of you that have heard of those things. So I wanted to, it's very easy to write a formal spec, and then, very easy. We all learn how to do it in grad school, right? You write a formal spec, you prove some things about it. It's great. But then, how do you know that the spec you wrote actually matches reality? And so I wanted to avoid the situation where we would write a spec which ends up declaring, and I'm not just concerned about the spec says 5 and the program says 4, that's just bugs in the spec, right? Okay, sure, we fix those. But I'm more concerned about the problem where the spec says, 80% of the code out there has undefined behavior. At which point it's okay, so clearly this is not actually a useful spec, right? People need a different language. If that's the language they actually have. So I wanted to avoid that. And so that is where Miri came from. So that way I could have some ideas for what the spec should be. I implemented the Miri and then I run it on some tiny pieces of code. And if that already explodes, then it's clearly no good. And so slowly over the years, I made Miri into a tool that can actually run on medium-sized pieces of code. It's still horrendously slow, but computers are really, really fast. So you can run them on sizable code. And so at this point, we are fairly confident that the semantics in Miri modulo a few places we know very well about because people send us bug reports. The semantics in MIRI are actually practical in the sense of they allow programmers to do enough unsafe code shenanigans that they can do the things that they need to get done while remaining within the scope of those rules. And so now we just need to take what MIRI does and make it into a like more condensed, purer artifact, which is what mini Rust is meant to become, and then eventually put in the theorem proof and things like that. So yeah, the main thing here is that like when you are, at least for languages like Rust, where there's kind of a bit like there's two steps to a language spec. There's like, is this even a valid program, or does it have UB or not? And then if it has no UB, what should it actually do? And for the first part, there's a very big risk that you specify your language in a way that completely ignores the needs of your programmer. And I think this is a real problem that the C and C++ communities are struggling with, judging from the fact that -f no strict aliasing is enabled in most major C programs. So there's lots of UB in the standard, which those people are turning off because it doesn't match their needs. And I would be very curious about the results of like running something like MIRI for C on larger C code bases. But it's very hard to do for C because C has a lot more determinism and a lot more UB as well. So I wanted to avoid that failure mode. And the only way I know how to do that is to just try it on real world code. So you need to have a tool like that, and then spend a lot of time on getting this tool into the shape it needs to have to be practical on real world code. So most of the effort we spend in MIRI is not figuring out the spec. I mean that's hard, but that's the easiest part, honestly. The next part is making it so that MIRI is just horrendously slow and not even slower than that. Which I mostly inherited, honestly, from the people that designed MIRI, but I had to add some parts to it to make MIRI cover more of the spec without making it slower than it already is. And then the other thing is that people, when you run this on real-world code, people will inevitably use operations which are not in your core spec, right? They will print to standard out, and they will ask the system for a random number, and they will, like, I don't know, set an environment variable. And so we have in MIRI thousands of lines of code of just implementations for all of these operations directly on the abstract machine level, so that we can run all of the code out there. And we have obviously only a tiny fraction of the real world APIs, because in the limit, this is like a full re-implementation of the full API service of like Linux and macOS and Windows, which we're not going to do. But we have enough to run like some interesting programs. And we have like ePOL now, for example. So we can run the core event loop of Tokyo, which is very unsafe heavy. So they really wanted to be able to test that. And you can run some simple async programs. Someone is implementing like file system access on Windows, because I wasn't motivated enough to do that for this other platform. But like it's slowly growing, and it's completely orthogonal to actually figuring out the details of pointer provenance, all of that stuff. But some of it is still spec work, because you want to, of course, model the abstract spec of these operations and not the actual implementation. But yeah, the point is that like there's a lot of these things that go into having a tool that can UB test practical code. And then once you have that, you can gain some confidence that your spec doesn't accidentally rule out 3/4 of your ecosystem. And I wouldn't know how to do a Rust spec with confidence without having tooling like that. That was basically
Yes, thank you. Wow, what a panelist. What a good set of panelists. Okay, let me move on to a common question in the same order. So the title of the first talk was Programming Languages Must Have Formal Semantics, period, right? So you need the formal semantics. Why the others? What are the formal semantics for, and what good things we can get from the formal semantics?
Right. So, well, that's definitely a very impressive title, I would say. But basically, so, ultimately, the argument is if you really care the correctness of a program, then a formal semantics is not an option, right? It's a necessity, right? Because without the formal semantics, then by definition, you don't know what's the behavior of the program supposed to be, right? So there's no point of talking about correctness. Of course, that's a bit exaggerated, but I think the idea stays there in the sense that ultimately formal semantics is not avoidable. So I think what's really probably more important is the implication of that argument, which is, if formal semantics is not avoidable and it's extremely difficult to develop, then let's make sure that we get the most out of it, which means that I, sit down, I spend, half a year, I understand one language, I have my formal semantics down, and that's it, right? So I want to generate tools, parsers, interpreters, compilers, debuggers, verifiers from that single semantics, because I spend a lot of effort in making sure that semantics is right. So I want a framework. I want an approach that can, cover the tooling part for me. So basically, we want to decouple, programming language design from programming language tool implementation. And I want to say that I think formal semantics one thing, and I think the specification language, or how do you want to present the specification of a programming language? I think that's a related but different thing, right? So within K, we also think about like I understand K is based on the rewriting term rewriting systems, and it looks pretty alien, right, to developers. So that's why we have this sort of like a documentation compiler, right? So you can kind of like a pretty printing a K definition into this graphical representation. But even that could look very alien, right, to developers. So I think we definitely need a variety of different specification languages, formal, informal. Just help, and they fit different needs, right? Sometimes developers just want to get a good understanding of something, or they want to see something executable, maybe. So I think we can have lots of different spec languages out there, but formal semantics, at least what we try to do with the K is that we acknowledge that it is difficult to do. So
one unique thing about K is that graphical visual representation. So I'm not sure whether that's approachable or accessible to usual developers. So my follow-up question is, can you give us some examples of outside users of K?
So we try to, so at some point we have some collaboration with the hospitals. So basically, they want to formalize the protocols of some like emergency procedures, like the
computer science.
Right, because you can imagine, right? So because sometimes I think it's actually during the COVID time, but the project itself is not about COVID. But basically, some people comes in, it's an emergency, and the doctor has to do some, follow some procedures, and depending on the readings from the patient, right? So the different procedures should take place. So they want to formalize that protocol, and so we use K, and apparently the rewrite rules are pretty much so sufficiently good enough, right, to the domain specific experts. Right, so of course they need some training, right, to understand. Actually, we didn't even show them the graphic representation. We just showed them the text version of K, which is like rewrite rules and so on. But yes, it needs some explanation, right? So what is the configuration? What are all these semantic cells? What's rewriting a red step means, and so on. But then things becomes like I would say okay-ish, right? So that's never been a bottleneck. But I think it's really boils down to the motivation. So in that case, right, so the domain-specific experts are motivated. There are incentives to understand what we do. But in general, if you ask a developer and ask them to read a write-based spec, they may lack motivation, right, to do that. So what's the point? I'd rather read something written in nicely in English with examples and so on. Yeah.
Thanks. So yeah.
Can I ask a follow-up
sure.
question real quick?
Yeah.
What makes K the right tool for that job? Like, I'm having trouble seeing what where would I use the interpreter, maybe? Or like, I'm trying, I don't quite see how I would use this compared to, say, just writing a pseudocode, maybe, which is more or less an algorithm, right? Might be how you specify procedures.
Right. So basically what they're looking for is some spec that is executable. And I think that just falls into the comfort zone of K.
Executable for a person, or executable on a computer?
On the computer, right? So they want to monitor the actual actions that the GPs are taking.
you do have some condition and actions, but there is a series of conditional actions. They never try to run it. So.
Okay.
Yeah, there are different people. Okay, so about P4, P4 has a language specification, but it's, yeah, I know. So what do you want to change in the specification? And in various P4 calculi, the papers say that if we have a formal semantics, then it'll be much better than now, things like that. So what would you expect to have a formal semantics for P4?
Yeah, so I mean, I guess I think it depends. The usefulness depends on the user and the community, right? For me personally, I would like to just look at it to understand what a program does. Get some of that sweet, sweet Greek back into my life, you know? And I think that would be excellent. From the community perspective, a lot of the people looking at this are not really programming languages experts, much more in the networking space. And probably they have no particular interest in looking at the actual formal specifications. But certainly they have a large interest in the artifacts that you get from those. Right? So insofar as a mechanized specification can give you, like we were saying, a reference interpreter, amazing. Right? Everyone would love a reference interpreter. That's great. Or make you able to make some minor change, and now the prose of the specification will automatically update to reflect that. Amazing. That also sounds great. I guess what I'm excited about for the future of the community is what it means for you. The ability, the fact that a language has a formal specification, I think makes it a stronger playground for PL researchers. Right? The things that you can do with it, just everything has a lower barrier to entry, right? When there's already a formal specification there in some sense. And there's already many papers on P4, mostly in the networking community, some also around here. But I mean, the stuff that PL researchers would come up with, I think is what excites me, personally.
Sounds good.
Not to pander to my audience or anything. But
yeah, thanks. So, as I said before, ES Meta and SpecTech are a bit different in the sense that ES Meta, ECMA 262 is the God, right? We just take it for granted and we use those terms and phrases in the specification and maybe a little extension later, right? But WASM SpecTech, here DSL is the first, that's the single source. So, about the ECMAScript specification, do you think it's possible or desirable to have some kind of formal rules in the specification? Or would anyone like it?
Okay, so I think we kind of saw a theme here, at least in a couple of the talks, about we need to have a specification framework that is appropriate for the thing you're specifying in each context. And in my talk, I made this argument that the thing we're trying to accomplish with our specification is that the engines that implement it are not going to diverge. They're going to implement the same thing. So it needs to be formal enough to get to that point while still being accessible for like all the different kinds of readers that we want to have. I don't see too many reasons at the moment to have any additional formality there. We are. If we were not able to get to the point that ES Meta has gotten to, where we can like generate this reference interpreter, I would say maybe that would be a useful case. So we can have like an oracle to test against. But like the language is regular enough that we're actually able to do that. Additional formality, I could certainly be convinced if given examples of why this would be useful, but without actually seeing the like practical purpose at the moment. I don't think that it's valuable.
So let me rephrase my question. Let's say we have another language, say P4 or Rust, another language to have well-defined, standardized specification. So which one do you recommend? Natural language or formal rules as the single source of truth?
Oh, that's gonna be so. That's so dependent. I don't think I can make that call, right? That's gonna be like really. You have to take into account all the factors around it. So, I'm gonna step away from that one.
Very dangerous question. Back to Ralf. What do you think?
I mean, I obviously think it should be something formal because that's how I did mini Rust. I mean, the starting point is very different, right? Like JavaScript had this already very detailed, very regular English prose specification. In Rust, we don't have anything like that. We at the same time we are kind of burnt a little as a community, I think, on the system side by having. I mean, okay, the term formal specification, to briefly define that, by that I mean like something mathematically formal. So I would call everything that is entirely just English normally informal. This your kind of English maybe is maybe that's formal, but like something like the C and C++ specifications, they are formal in the sense of like being documents adhering to a certain form, but not mathematically formal. And there is a big problem there about the ambiguity this creates. And it's causing actual issues, and like researchers trying to define the spec of C and C++, and then, well, who knows what the spec is, right? We need to talk to the committee. Committee, like, well, how long does it take to resolve all these questions? It took 10 years to resolve provenance, and it's not in the standard. So it's a technical report. So like there's kind of an example of this going wrong, or at least like not as well as people in the Rust community would like it to go. And so I think in that sense, they were very receptive to the idea of starting with something very rigorous. And also from my side, it was an entirely pragmatic choice. I mean, if I wanted to do this in natural language, I would have to develop serious amounts of tooling that can then actually make this executable. Whereas this way, I could just write some code, and then I could put a master student on making it executable, which was it was basically translating it from almost Rust into actually Rust, and then we can run it. So it's a very pragmatic choice to get started. And at some point, we'll have to figure out how to incorporate this into the Rust standards process, which there is a natural language specification being developed there. And whether these will be just separate artifacts that are manually kept in sync, or one is derived from the other, or the other derived from the one, I think that's still largely open. But the choice for me was a pragmatic one, maybe also a lack of creativity. Like I didn't think you could actually do this English language thing as well as JavaScript seems to have done it now. Maybe this would also work for Rust. I think it's a bit trickier in Rust because the language has like all these weird like ghost state things which don't actually physically exist, but in principle it's all just operational semantics. You could express it. So yeah, but I mean I'm a PL researcher, so of course I default to doing this in a formal way.
Exactly. So I understand that that's a pragmatic choice for now. But do you envision, or do you want to have mathematically formal specification? Not at all about natural language, but formal semantics for Rust.
Yeah, I mean definitely. Like I mean we want all the, like as you already mentioned, all the nice tooling that comes out of that. Something like, I mean, and in Rust it's kind of, we're doing it a bit backwards, where we first have Miri and then we extract the formal semantics from it. But of course, going forward, we hope this will be the other direction. Like as language extensions come, they are specified. And then they're just implemented in Miri. So you need formal specifications for tooling like that. And Miri has been very successful as finding UB bugs like all over the ecosystem. We can find similar success stories in neighboring parts of the ecosystem. For example, in LLVM, they have this tool called Alive, and now Alive 2, which has found tons and tons of bugs in optimizations, which is now routinely used by LLVM programmers. So LLVM has become, so Alive, the encoding of LLVM semantics in Alive has kind of become a de facto semantics for the fragment of LLVM it can handle. And you can't have Alive without formal semantics, because what's it supposed to tell the SMT solver, right? Like, can't send a bunch of English there. You could try this with an AI, but I wouldn't recommend. So like I think like what you get out of this is this tooling, and at the same time the tooling is how you convince the practitioners that it's worth it, right? Like we've been telling, obviously, if the LLVM people had ever asked, we would have told them for decades that they need a formal semantics, but they would have been like, why? But now we are getting to the state where there's very concrete benefit from these kinds of tools, and that is what convinces practitioners that it's worth spending the effort of like working on a spec, or at least supporting the effort if some academics show up that are crazy enough to do the work for them.
Great to hear that. Okay, so let's take some questions from the floor. Yes. Oh, that's the mic.
Oh, that's the mic. Yeah. Thank you. So when we have a formal specification, or mechanized specification rather, we can generate a reference interpreter for a language. Maybe my question would sound too naive, but I will still ask it. Is there any hope that actually practical implementations will also be somehow generated? Does it make sense at all? Or, yeah.
Okay, right. So I think maybe the elephant in the room here is the performance, right? So you pay a cost by having these auto-generated tools, and in K, we currently stand at a 1 order of magnitude slower than a handwritten interpreter. And there are various optimizations you can do, right? So you can do it on the K side, on the interpreter side. And there is also something interesting you can do on the semantics level, which is basically, so we call it semantics-based compilation. So what it does is you can have a program, and you can execute the program symbolically as much as you can. And every symbolic execution of a basic block gives you a semantic rule, which is essentially like a partial evaluation of the program, right, using the semantics. And in principle, that's a compiler. If you think about what a compiler, well, a compiler is the partial evaluation of an interpreter given the program. So you can do that symbolically. So, and the result of that is a new semantics, but that semantics are specialized for a program. So it's as if you're doing compilation at the semantics level. So that's like a semantics level optimization. So, all these are like work in progress. So we do hope, but I think the performance is definitely one of the big issue, right? But I think we are getting closer and closer. I think one lesson that we've learned in K, in the K area, is that if a methodology works, then there are always going to be engineering advancements that make things faster. Yeah.
Right, but I mean, I don't know if you were asking about production like compiler interpreter. I think for the compiler part, my answer is no. I mean, you said it's 10x slower than a handwritten interpreter, and that's still like, what, 1,000x slower than the compiler in -0 or something? I mean, so this is not going to replace the actual compiler you use for your production-grade code. I mean, on the interpreter side, there's also very cool things like meta-tracing compilers. I don't know if anybody tried that for K, but I would recommend looking into it. It's very cool tech, basically JITs for interpreters to get runtime binary code. I want to try this with Mini-Rust one day. But like for deriving the actual compiler on the backend side, like you're not the amount of engineering effort that goes into making LLVM practical and fast is not going to be replaceable by anything like this. And it's not just the backend, right? Like you can, I mean, we've had parser generators for decades, and yet no practical like production grade compiler uses a generated parser. Because with a generated parser, you get terrible error messages and like often also not great performance. So this is an area where we've had generation for much longer than for the backend part, and yet we don't use it for the production-grade compilers because it's just not good enough for what users actually need for the production-grade tool. So I think those will remain separate, but they can be very useful as like fuzzing oracles and things like that.
Hi. So I've got a comment and then probably a question-ish, if I can turn it into a question. So Michael said my favorite quote of the day, which is, let me know if I say industry jargon that's not real world. I thought that was... Yes, sorry, Jonathan. I'm going to talk about to Michael, so I've got in my head. So now for Michael, so you said that we did some JavaScript work, mechanization work that was not useful because it went for, it doesn't matter. It's fine, but I am going to challenge you. Because we did ECMAScript 5 strict, and then it got to ECMAScript 6, double in size, good strategy. And we stopped at that moment for obvious reasons. But in particular, for our point of view, it wasn't about immediately going to the standard, although we were talking to the standards a lot. We enjoyed very much those meetings. In fact, we were after the methodology of how to do it, and that methodology turned into WASM-cert. And WASM-certs, for many reasons, turned into WASM-spec-tech. So in particular, this is all about methodologies. So there's the short-term notion of useful, which is that standard can use it now, and then step back, the more long-time notion of useful, which is the methodology. And now we're on the methodology of the WASM spec tech and what we can do. So in particular, whether it would be our version of how to do it, or ES Meta, or Ralph's work on Mini Rust, in our different ways, we are creating methodologies for that future. And so I guess the challenge for the room and the question for the room is, for those next languages, what do we need to do in order for those standardization bodies to be receptive for these methodologies? So I think that's where we're at.
Yeah, thank you. Thank you for the nice summary. And do you have something to say?
I agree. It was the friends we made along the way that was the value there, and I didn't mean to diminish that. Yeah, I guess repeating myself from earlier, the things that we need to do to make to get that like immediate value for the standards bodies is to have that continued like support of these living standards. All the web specifications are all living standards. They're constantly evolving, and taking these like snapshots in time is while useful for learning and methodology right there, is not useful tomorrow, as soon as things change.
And I almost think it's more than this. So one thing I was really surprised about by engaging with the JavaScript standard was actually you guys were formless. You didn't have the math, but at the same time, the precision with which Mark Miller, others talk about what they are doing is impressive. And so, in my world, I would write that precision in mathematics, and then almost I can hand wave after that because I've got the language to be precise. So in some sense, it's given that wonderful group of people in the JavaScript world, what happens over the years that one gets them, I say a little bit arrogantly, I don't mean it like this, to the place where actually they might write it down in a way that gives them the freedom to be more hand-wavy in their speech.
Okay. Any question? Yes? Oh, 1 second, Ralph, and then, yeah. Yeah.
I mean, so that is a challenge.
Good challenge. I think you were also asking about how can we make this more accessible to the communities? How can we make them more likely to adopt this? We're about to see how this goes with P4. The co-chair is only as good as his community, so I'll see what I can do. I'm also from the P4 language community, right? From the programming languages community. So I'm of course supportive, but yeah, P4 and PL. Anyway, I think it's almost exclusively, with maybe 2 exceptions, a human problem. Right, and I mean this is kind of part of it. What makes it tricky? You can't just sort of technical away until now you're done. Now there are technical things, right? Like showing people what they get out of doing this adoption. That's huge. But otherwise, you need to integrate in the community, start early, start getting them used to the idea that this is a concept that you might even possibly get into, right? And then you have to meet them where they're at, and this occurs a lot in industry, but I find is often a very hard and painful thing as a programming languages person. Sometimes when they're wrong, you just have to do their wrong thing and formalize that. And that's really hard, both mentally, like, is this what I want to do? And also, like, sometimes actually, because it makes your specifications real weird sometimes. But then once you have it, the formal specification there, now you can be like, well, look at these 3 segments. These are kind of weird mathematically. Should we try to like simplify this part by removing this? Right now, you can move to the more beautiful world that you maybe were envisioning for the language in the first place.
Right. Before Ralf, yeah. Are you done? Yeah, I mean, our guy working on P4, P4spec, he had this table, and he's just pointing out, this entry is empty. It's undefined. And before having all those semantics spelled out and all those discussion with the community, we didn't know and they didn't know and they still don't know. So it takes time. It takes time to understand their weird word and weird semantics and describe that precisely and talk over and over again until we understand each other. So I think that's the human factor that we are willing to take to make a big difference. Thank you. You're done?
I was just going to mention this is not really an answer to the question, but sometimes the way this can happen is also if the communities realize by themselves that the way they have been doing it doesn't work. So like if they've suffered for sufficiently long from their informal specifications, that you can offer them a better way. Like I think this is currently happening in the C++ concurrency memory model world, where they had, like, for the latest revisions of the standard, they meant to basically just copy a certain part of a paper and make it part of the standard, and they made a mistake while translating the paper formalism into English, and now the standard doesn't say what they wanted it to say. And this has been not the first time they have problems there, but like at least some of the people in that community are now, from talking with them, ready to go to a world where the formalism is the authoritative spec and the English is just explanation for it, just because they've been burnt by lack of rigor in the English. Because these people are very good at making the English precise, but there is a limit to how far you can stretch that until you, like, it's just really, really hard to do it without an actually formal language. So that's not a recipe. You can't obviously, you don't want to make a community suffer for a decade before they then come to you for a solution. But some communities are in a spot where it's just much harder than it seems to be in the JavaScript space, for example, to actually make this sufficiently good and with pure English.
I think that's right on the right track. This question, I think, is getting at, just having a shared vocabulary for being able to be precise. And you may be more comfortable or familiar with this like shared vocabulary you have with your colleagues that's more mathematical, but Paine has evolved this use of English within the spec, within the committee, as you mentioned, for all of these the participants to be using these terms that are all very, very clearly defined to each other. And they may sound actually like generic terms if used outside of that context, but within that context, they have a very, very specific meaning. And you have to be aware of it by knowing the hundreds and hundreds of defined terms that we have in the spec that we use to communicate with each other. But like absent that pain, I think it accomplishes the same thing. We are able to be precise in our communication with each other, and if we were not able to evolve into that space where we are now, we probably would have moved to these other more common formalities.
Sorry, I want to ask a really short question. So I want to ask about everyone's general strategy or approach to really making a programming language specification. Like more specifically, if you are told to write programming language specification right now, what would you do? What is the first thing would you do as your approach? I want to ask about that.
And my two-word answer is write a reference interpreter.
Similar to that, but of course, if you were to do it with K, right? So the first thing would be to try to understand the runtime model of that, and basically, using KAIST terminology would be started with the configuration. So what is the state basically with all the pieces of semantic information that you have to know if you want to execute the code, right? So for example, if you're writing spec for a multi-threading language, then most likely there should be some the structure represent holding all the threads and so on. So start with the configuration and do just the minimal amount of syntax so that you can write some simple programs. and then add semantic rules on the fly, right? So, but I think the configuration and understanding the runtime state of the language, and of course that's not something you do. You finish you complete at the very beginning, but start with that and then evolve from there.
Are we talking about like my language specifically or languages in general? Feel free to do a gesture. Got it. For languages in general, okay, production language. Oof. See, now it suddenly got hard. I was going to say for my language, of course, I just talked to Jae-Hoon and Sukyoung and say, pretty please make me a formal specification. I guess for languages in general, I'm much more on the production languages in general. I'd be much more on the Ralf side here. I'd want to do a reference interpreter. For some small domain-specific language that I was designing, I go straight to the math. I just write a denotational semantics or an operational semantics.
I'm going to, again, give you the Weasley answer. I think it really depends. You have to... Yeah, you...
42, right? Okay, then next, last question.
Yeah, thank you. So for the context, Yulia from Mozilla and myself, we are at the JavaScript committee. We are trying to bridge industry and academia. So I actually have a question for you, Sukyoung. So what would be your advice to the PL researchers who are here, who want to contribute to widely adopted languages and their standards?
Ooh. Can I answer this question? Anyone first? Yes?
Yeah, maybe I can start. So one thing I learned from not my work, but actually at this Daijun Park work on defining the semantics of JavaScript, is that something basically you can generate a lot of test programs out of the semantics. And I remember one thing that Daijun did was he defined the semantics of JavaScript, and he ran the existing JavaScript benchmark programs using the semantics, and to test the coverage of the semantics, right? So and he observed that some semantic rules have never been triggered, right? So he wrote some more JavaScript programs, to cover those, corner cases, and then he tested the, at the time the like Chrome and Firefox and so on, right? So it's using the new benchmark programs. I found a couple of bugs in those. So I think that could be one way, right, for specification language to help. So basically, once you have a specification, generate some programs, right? So make sure that you have a very solid, comprehensive benchmark programs, because they'll be very useful, right? So for production tools and so on. Yeah.
Now I have some answer, maybe not the right answer. I think what Michael said is really important. We need to have shared vocabulary. When we say specification, we think something different. When we say formal semantics, we think something different, right? And everyone has different interpretation and different value. And the important thing is that we do not need to compete. Like there's K, there's others in JavaScript and WebAssembly. They may interact each other. Like I was interested in this question, like K, it's really well used in some languages, but does it also cover interoperations with different languages and all sorts of questions? And so I think this could be some starting point that we get together, learn from each other, and maybe next time we invite Peter to give 5 hours lecture. I think it's gonna be more than 5 hours, right? Like 2 days or something. But I love to hear that, and I hope we can learn from each other from now on. Okay. So with that, thank you for the long day, and let's give them big hands.